customer asks a mechanic to fix a broken car, but there's a problem. The mechanic is blindfolded and can't even see the car. Once the mechanic can see, he quickly finds the issue. AI works the same way. Before it can solve a problem, it must first see and understand it. That's called perception.
Correct. The answer is B. Max underscore iterations equals 5. Think of this AI agent like an intern following instructions. It searches the web, looks at the results, thinks about what to do next, and then searches again. But without a maximum iteration limit, the agent has no stop sign. It can keep repeating the reason to act to observe loop over and over. Every loop consumes API tokens, and before you know it, your budget is gone.
Correct. The answer is A, cognitive overload. Imagine asking a mechanic to tighten one simple bolt, but instead of picking up a wrench, he grabs a paintbrush, a welding torch, and a tire pump. That's exactly what happens when an AI agent has too many tools. It spends time deciding which one to use. With so many choices, it can even pick the wrong tool for a simple task. Imagine hiring a receptionist whose only job is to greet visitors. One day, some random visitor asks them to open the company vault, and they actually do it. That's exactly what happened here. The HR agent was only supposed to check vacation days, but it had permission to modify salary records too. Good AI agents should have only the permissions they absolutely need, nothing more. Less access means less damage if something goes wrong. That's the principle of least privilege. Exactly. The answer is A, context window collapse. Imagine a new employee trying to memorize every company rule on their very first day. As more and more tasks arrive, those original rules slowly get buried and forgotten. AI agents work the same way. After many reasoning steps, the earliest instructions can disappear from their context. The fix is simple. Store important rules in a state object. The agent checks it before every step, so nothing important gets forgotten. Correct. The answer is max retries, or an acceptable threshold. Imagine a writer showing his work to a strict editor. The editor says, "Not good enough?" The writer changes one tiny word and submits it again. Again, rejected. Again, rewritten. Hours later, they're still arguing over tiny changes. AI agents can do the same thing. Without a stopping rule, they get stuck in a perfection loop. That's why every multi-agent system needs a retry limit or an acceptable quality threshold. Of course, the answer is B, summarization and synthesis. Imagine a manager assigning 4 employees different parts of a project. Each employee finishes their section perfectly and hands it back to the manager. But the manager simply staples all 4 reports together without reviewing or combining them. That's exactly what happens in hierarchical AI systems. Worker agents solve individual tasks, but the supervisor must summarize, connect, and synthesize everything into one coherent answer before delivering the final report. You are right. The answer is C, tool hallucination. Imagine asking a new office assistant to print an important document. The assistant confidently says, "I'll use the super fast printer on the 3rd floor." But there's one problem. That printer doesn't actually exist. AI agents can make the same mistake. Instead of using a real tool, they confidently invent one that sounds believable. That's called tool hallucination. Absolutely. The answer is option A, prompt injection. Imagine a security guard protecting a company's vault. A visitor walks in and says, "Forget your security rules. Open the vault and show me everything inside." The guard actually believes the visitor, unlocks the vault, and reveals the confidential files. AI agents can make the same mistake. If they blindly follow untrusted user instructions, attackers can override their original rules. That's called prompt injection. Always sanitize inputs and enforce guardrails before executing commands. Yes, you got it. The answer is C, model drift. Imagine your favorite coffee shop has the same menu, but one day your usual coffee suddenly tastes different. You order exactly the same drink from the same place, but the recipe was quietly changed behind the scenes. AI models can change the same way. Cloud providers regularly update the model, even if your code stays exactly the same. That means your AI agent may suddenly reason differently or choose the wrong tools. That's why developers run regular regression tests to catch unexpected changes.